Okay, so for the first step of this reaction, we have an alkene, specifically a 6-carbon alkene, and we are getting a 3-carbon aldehyde out of that. It might help to draw out our implied hydrogens. If you find it helpful, I recommend it. So we're getting a shorter carbonyl compound from an alkene. Instead of 6 carbons for the alkene, we're having 3 carbons for the aldehyde, implying that this molecule is going to be split. And so what we're going to do here is called an oxidative cleavage, because not only is it being split, it's also being oxidized. And so what this is going to be called ozonolysis, in which our reagent is going to be O3, which is ozone. And there's also going to be a second step to the reaction, being zinc and hydrochloric acid. The mechanism for this is fairly complex, so instead of memorizing the mechanism, there's a much easier way to know how your products are going to turn out, still mechanistically though. And that is to find your double bond in the original molecule and the precursor, and draw a little split through that double bond. And then it helps to draw it in a similar shape to the original at first, and especially to number the carbons exactly the same as well. And hopefully you can see the similarities here between these two, because these are the products generated from this reaction. In this case, it happened to be the same product because it was an even numbered alkene where the double bond was in the middle. And so this is how we get specifically the 3-carbon aldehyde propanol from 3-hexene. The second step for this synthesis is going to be reacting that aldehyde that we got with lithium aluminum hydride. And really what should also be written is that as the first step, and then H3O plus as the second step. So your lithium aluminum hydride is acting as a reduction agent, in which we're adding hydride to the carbonyl carbon. And really, and this is just a little bit of how it works, it's sort of like adding a hydride to the carbonyl carbon, and essentially you get a hydrogen on the carbon that wasn't there before, and you've also broken the double bond, which makes the oxygen negative, so you've made an alkoxide. So this is the first part of the reduction reaction, and then the second part will be protonation with the H3O plus. That gives us propanol, and that's our second product. And a side note is that for ketones and aldehydes, sodium borohydride is honestly the preferred reduction agent. Lithium aluminum hydride, LiAlH4, is preferred for carboxylic acids and carboxylic acid derivatives like esters, amides and hydrides, and acid chlorides. But this is the second product, will be propanol. This last step of the reaction, we're converting propanol to propyl bromide. And so whenever we have a primary or secondary alcohol and we're reacting to get a primary or secondary halide, that's going to be SOCl2 for chlorides, phosphorobromide for, or PBr3 for bromides. So PBr3 is going to be our selective reactant here. Ether is a good solvent for that, a non-reactive solvent. Since the stereochemistry here isn't specified, there's not really a need to go into the stereochemistry for this reaction or to specify the stereochemistry for this specific reaction. However, the way this works is that, let's use a secondary alcohol since that's a little easier to draw out the stereochemistry with. So what happens here is that the oxygen from the alcohol attacks the phosphoryl group, kicking off the bromide. And what that gives us is, oops, let me rewrite that. What that gives us is, we're gonna have BR. Alright, and that gives us our intermediate. The final step in this, since we kicked off a BR, is going to be that this BR comes back and it's going to do a backside attack. It's going to do an SN2 like attack on here. And so it's coming from the backside of this hydrogen here. And so what this is going to do is it's going to force the hydrogen bond forward while the rest of that mess of a PBr2OH molecule gets kicked off. And then on the back you have the bromide that added. So this is an example of the mechanism as to how the PBr3 works. But for this example here, for our synthesis problem that we just did, simply you react PBr3 with a primary alcohol or a secondary alcohol to get a halide, to get a bromide specifically. If this were a tertiary, by the way, you would use HCl or HBr. But there you go.